All right, let's play chemical detective. We're going to solve the mystery using the tools of qualitative analysis.
So you're in the lab and you've got this unknown liquid. The big question is, what's actually in it?
The whole process is called qualitative analysis. It's not about how much, it's all about what.
So how do we do it? With something called a reagent. Think of it as our chemical magnifying glass.
And when we add it, we might get a solid, a precipitate. That's our #1 clue.
But first things first, the easiest clue is just looking at the color of the solution itself.
See those elements in the middle of the periodic table, the transition metals? They love to make colored solutions.
So if it's blue, you're probably looking at copper. Yellow or brown, maybe iron. Simple, right?
Okay, time for the main event. Let's add our reagent, some good old sodium hydroxide.
If we add that to our copper solution, bam, we get this really distinct pale blue solid.
But with iron? Totally different story. A reddish-brown solid appears. See? Different chemical fingerprints.
But what if the solid is white? Well, now things get a little bit tricky.
That's because ions like zinc and lead will both give you a nearly identical white solid. So which one is it?
How do we tell these lookalikes apart? Easy. We just need to run another test.
And that's where ammonium hydroxide comes in. We add excess of it and watch what happens.
Does the white stuff dissolve? Then it's zinc. If it stays put, you've found your lead. Case closed.
And that's really the heart of it, using clues like color and solubility to figure things out.
So, to recap your detective kit, observe the color, reacted, check the result, then confirm.
And, these ideas aren't just for identifying salts in a test tube. They're much bigger than that.
These same principles help explain how alkalis react with solid metal oxides, not just dissolved ions.
Which makes you wonder, what other invisible stories are out there just waiting to be told?